In this video, we're going to talk about some properties of logarithms. All right, we have the product property, quotient property, and power property. And with these, let me just kind of go over them really quick and we'll try some examples. All right, this first one, the product property, basically if you have a log with a base, all right, and then you have two things that are taking the log base of that, right, like here m times m, if those are being multiplied together, you can expand that to say log base b of m plus log base b of n. Right now, if that's called the product property when they're being multiplied together, if they're being divided, just like over here where you add it together, now you're going to subtract. All right, so if it's log base b of m divided by n, that's going to become log base b of m minus log base b of n. All right, and then one other one here is the power property. If you have log base b of m raised to the n, then what you can do is take that power and put it in the front. Okay, so it's going to be n times log base b of m. Now, one thing to note with this before we try our examples, and that is that this left side for this one, this one, this one, that's all going to be what we call the condensed version. All right, so sometimes on your assignments, they're going to have you either take the expanded and condense it, or you're going to be given a condensed one, you have to expand it. Right, the other side is the expanded one. So with that said, let's try some examples. All right, these first couple problems that we're going to do are going to be some condensing. All right, they're going to give us the big expanded form and we have to condense it down. And then the next couple we're going to do are going to be the opposite, where they give us the condensed, we have to expand it. Then the last ones we're going to do are what's called a change of base formula. All right, so stick around to the end if you want to figure out what that is. But anyway, let's get into this first one where we are condensing this kind of big, long chain of logs, if you will. And we're going to put it together. Now, what I like to do personally first is anytime I see a number in front, all right, so like right here, there's a 2, that's going to be using that power property where it's going to kind of go up. All right, I even sometimes draw an arrow to remind myself it's going to become the property on what that log is taking, what that log is of, right? So in this case, it's a common log, so you can think log base 10 raised to, this case, it's going to be 4 squared. All right, so I'm going to bring down the rest, and I'm just going to make that one change. Log of 4 squared, right? Because it becomes the power. The rest of it stays the exact same, minus log of x. None of those other ones have a number in front, so it's just that one with the 2. Okay, then let's kind of, after you do that, I kind of like to make a game plan as to what we're doing. And in this case, I'm thinking I'm going to have, so our goal is to end it with just one log, right? So I'm going to end up with that log, and we're going to be putting these two together, right? It's an addition, so I have to put it together with multiplication for those two parts, and then it's going to be divided by an x. So if I do all of that at once, you can, and here, if you think 3 times 4 squared, well, that's going to be 3 times 4 squared, of course, is 16. This would all be divided by an x, all right? So our goal is to get down to just one log, and once I have that, make sure that the rest of it's simplified. I can do one more thing here. 3 times 16, of course, is 48. So this is going to be log of 48 over x would be my answer, the condensed form of that part up there in red. Okay, let's try one more condensed one. This one's going to be a lot harder. So it says 0.5 natural log. Okay, that's log base e, and same idea is in the natural log base e. So 0.5 natural log of 9 minus 7 natural log of x minus 6 natural log of y. Okay, whenever you see two subtraction signs next to each other like this, what you're thinking is there's going to be two things down in the bottom of that log. All right, and to kind of prove that to you, I'm going to take this part and we're going to factor out a negative, all right, before I even get to this number in front. So, oops, not log, natural log, my fault there, of 9. And then I'm going to take, like I said, I'm going to factor out a negative from both those. And so it's going to be 7 natural log plus, because we factor out the negative, 6 natural log of y. Okay, now I can, oops, I forgot an x in there, I think. Now I can go ahead and do the power property like we did with the 2 on this one. And each of these are going to get something, right? So this 0.5 is going to go there. The 7 is going to go with the x, I think. And the 6 is going to go up with the y. All right, let's do all of that. So now I'm going to have the natural log of 9 minus, this is still in parentheses over here, the natural log of x to the 7th plus the natural log of y to the 6th. And then close your parentheses. All right, Now it's part in parentheses. Normally when we see parentheses, like order of operations, we do that first. That's going to be true here as well. So I'm going to have the natural log of 9 still out front. Haven't worked with that yet. But these two can be put together as one log, one natural log with a multiplication sign, or they're going to be put together using multiplication. I'm going to say minus, and then since I'm putting them together, I can drop the parentheses. Natural log of x to the 7th times y to the 6th. All right, you can put a dot there if you want, or if you have two letters next to each other, of course, that means multiplication. All right, then there's only one other thing left, and that is the minus there in the middle. Oh, you know what I forgot? I think I need my 0.5 on here. 0.5, 0.5. And by the way, remember, if you have 0.5 as your exponent, that's like taking the square root. So for example, if I have 16 raised to the 0.5, that's like the same thing as the square root of 16, which of course is 4. So in this one, this is like saying this natural log square root of 9, which is just going to be the natural log of 3, because the square root of 9 is 3. So I'm going to do that. I'm going to say the natural log of 3, because I forgot to earlier. And then instead of minus, right, I'm going to make this as division. So I might put it kind of up here and say 3 over, and then this bottom part is just going to be x to the 7th, y to the 6th. And I have that now written as one single log. All right, and there's nothing else I can simplify there, so that one is done. All right, let's try some now where instead of condensing, we're going to expand these. All right, these next two problems, like I said, we're going to be expanding them given the condensed form. So this first one here says log base 2 of 5x over y to the 4th. Okay, so a couple things are happening. Sometimes it's good to kind of see how many logs we're going to end up with when we're done. And in this one, what I'm seeing is we have a 5, an x, and a y, all right? So that's going to be 3 logs when we're done. That's 3 log base 2s. So let's start here, just kind of, let's undo this division, and that's going to be done with subtraction. So I'm going to have log base 2 of 5x, and then remember, the division is undone with subtraction, so I need another log after that, another log base 2 of that part that was subtracted, or that was divided, which here is going to be of y to the 4th. Okay, and then I can undo the 5 and the x. And remember, since that's put together with multiplication, we can undo that with addition. So I'm going to say log base 2 of 5 plus log base 2 of x. All right, and then while I'm here, instead of just saying minus this again, I'm going to say minus, and then I'm going to use the power property to bring that in the front. So I'm going to say minus 4 times log base 2 of y. All right, now let's just double check here. Is there anything else I can do to this? Well, it's log base 2 of 5, log base 2 of x, and then a 4, log base 2 of y. No, that seems like everything there is done. There's no other thing that I can simplify, so that would be my final answer. All right, again, I'm going to do another one where we expand this. It's going to be a little bit harder because it has a square root. Got to remember what that means exactly. And in this one, again, how many logs should I end up with? Well, I have a 10, an x, and a y. So I think, again, I'm going to have 3 logs by the time I'm done with this. So let's start here again by undoing that division with subtraction. So let's see here. Log base 5 of the top is going to be, in fact, that top I might just rewrite in parentheses as 10 times x raised to the 1/2. Okay, let's get rid of that square root by raising it to the 1/2. Talked about that earlier. Okay, and then on the bottom, so I'm going to say minus y, or I'm sorry, log base 5. I need my log base 5 of y to the 7th. Okay, and then 2 things I need to do. First off, I need to split up the 10 and the x, right? And then the second thing is I need to also get rid of my exponents using the power property. And because it's in parentheses, you might want to do that first. All right, let's watch what happens when I get rid of these exponents. So here my 1/2 is going to come in the front, and so is the 7. It's going to go there and there. So I'm going to be left with 1/2 times log base 5 of 10 times x. And then over here, minus 7 log base 5 of y. Okay, but I'm not done yet because the 10 times x, that needs to be split using addition still. All right, so if I do that, think about this for a second. Up until this point, we've been using the whole log, right? And now that's going to have a coefficient in front of it, which is 1/2. Well, remember that was applied. This is the square root of 10x. And so this 1/2, because that's what the square root is, it's the power of 1/2. It's going to be applied to both of those, the 10 and the x. So they'll both be 1/2 log base 5 of 10, 1/2 log base 5 of x. Okay, so I'm going to do that here. 1/2 log base 5 of the 10. And again, since it's being put together with multiplication, I'm going to say plus 1/2 log base 5 of x, right? Minus, and this part is already kind of done, 7 log base 5 of y. All right, and again, just double check, is there anything else you can do to this? No, so I think that is my final answer over here. And again, that's how you expand these. All right, the last property of a logarithm that we're going to learn today is going to be what's called the change of base formula. Okay, and this one can be done one of two different ways. So whether you're given log base b of a, or again, log base b of a, it can either be log of a over log of b, or you could use the natural log of a over the natural log of b. So you're going to need a calculator for this. As it has, for my calculator, we have log and natural log right below my second button on a TI 30. I know for, I think, some of the TI 84s, the log buttons are down a little bit. So find those buttons on your calculator. And the way I like to remember this is when it's written over here, the A is kind of on top and the B is on the bottom. And that's the way it's kind of written as well. So for example, over here, if I were to calculate this, when I have log base 4 of 9, I would say log base, or log, not base anymore, but just the common log of 9 over the common log of 4. And let's type that in your calculator. All right, so log of 9 divided by log of 4. You might have to be a little bit careful, close those parentheses so you don't actually take a log of a log. But anyway, here you get 1.585. So equals 1.585. I usually make my students round to about 3 decimal places or so. And now it's going to look like I have a typo, or like I wrote this wrong on my board up here, but this is the same problem, because now I want you to try it again with the natural log. You should get the exact same answer. And you take the natural log of 9 over the natural log of 4. All right, and just to prove it to you, I'm going to do it here. The natural log of 9 divided by the natural log of 4. And yes, you get 1.585. 1.585 rounded to 3 decimal places. Okay, let's do one more really quick. You can either choose log or natural log, whatever you like. I'm going to do the regular log, the common log of 125. Oops. That is 152. Come on, man. Of 125 over log of 25. All right. So let's do that here. Log of 125 divided by log of 25. And this gives me just 1.5. Okay. Because this is my theory, because 25, or because 125 is a multiple of 25, here's turns out a little bit nicer for an answer. You just get 1.5 with no rounding necessary. All right, so those are some properties of logs. If you found this helpful, you might find this video on logs also helpful. And until next time, keep doing your math homework fast and accurately.